Welcome back, Algebra 3. We're in Lesson 10. So we remember the equation of a line is y equals mx plus b, where m is the slope and b is our y-intercept. And it's the y-intercept whenever it is y equal to y. Okay. So we remember that whenever we have a flat line, like let's say we have a coordinate system here. Ooh, that's not very straight, is it? Here's a coordinate system. And whenever we have let's make that a little more proportional there. Let's use this blue line here. Whenever we have a line that goes directly across the y-axis, where every value of y is the same, regardless of what the point is on the x-axis, the y value is always at this level. Then we're going to say y is equal to, and let's just say that's 1, 2, 3, 4, 5, let's say it's 6. So y would be equal to 6. Now when we have a vertical line that's straight up and down, every value on the y-axis is going to have the same value on the x-axis because it's stationary on the x-axis. So when we have one like that, we say that x is equal to, and in this case it's 1, 2, 3, 4, 5, 6, 7. So we don't have a slope. It's a flat line or a perpendicular line. It's either going to be a horizontal or vertical line. And there is no plus b. There is no mx. This is the intercept for that axis. It's just straight across or straight up and down. When we have the equation of the line, there are other factors going on that creates a slope. And that slope, let me switch over to green so we can look at a different color here. Let me get this line. So when we have y equals mx plus b, we have slope and we have a y-intercept, and they react to one another such that there is created an angle. That angle could be this direction, or that angle could be down from left to right. So up from left to right or down from left to right. And if it is up from left to right, then it is a positive number in the slope field. If it is down from left to right, then it's going to be a negative number. So we would say a positive when it goes up. Let me erase this. When it goes up, we would have y is equal to mx plus b. And if it's going down, then y is equal to a negative mx plus b. And then wherever that line crosses the y-axis, that is going to be the value of this plus b right here. We determine slope by the angle of the line in regards to how far it moves down the y-axis or up the y-axis as it travels from left to right. And we write that as a ratio or a fraction. Sometimes it can be simplified into a whole number. Sometimes it can be reduced. Sometimes it can't. So for instance, if we have a line, let me get another page here that might help a little bit. Let me clear this. I don't know what this was, but it was cute. So here's our just a little illustration of a grid, a Cartesian coordinate system here. This is all just a refresher. You guys should know this pretty well. Let's say we have a line that I'm going to start it here, and I'm going to not do that. That's a curve. I don't want a curve. I want to make sure that it crosses at a point is what I'm trying to do here. All right, so cross at a point and cross at a point. All right, so there we go. So it goes on in each direction. Here's our line. So here's our y-intercept point right there. And here's another point on that line where it is intersecting two marks that makes it easier for us to find the point, right? I don't like doing coordinates where it's, 1.5 or 1 1/3 or any kind of decimal. It's easier when it's whole numbers to me. So we can begin to write our equation of the line by saying, okay, y is equal to, we know there's going to be some value that for the slope that is multiplied by the x, but it is at the 1, 2, 3, positive 3 when it crosses the y-axis. So now we can just find the angle of the slope, and actually there's a point right here that's the next point. And if we look, we go over 1 and up 1. Now when you go over, that corresponds to the x-axis. It's the same direction as the x-axis, and the x is on the bottom. We always write it y over x for slope because it is the change in y over the change in x. So we have the change in y, the next point goes up 1. So on the y-axis it goes from here to here, that's 1 space. So that's 1 for the y-axis, and from here to here that's 1 space on the x-axis, 1 over 1. We can simply write as 1, but when we have a variable, we don't write that 1 in front of it. We just assume it's there, right? So our slope for this line is going to be 1. Whenever you see x without a coefficient, the slope is 1, 1 over 1. And then the y-intercept is always 0 for the x, because the 0 on the x-axis is right here. So the y-axis, wherever it crosses, that's your y point. And we take that from this number right here. So it's easy to write a linear equation when we see a line graphed where it has points indicated, and then we can count. Now, even if I had used this point here, I could have said 1, 2. That would have been 2, and then 1, 2 over 2, which is still equal to 1. Same thing. All right, so it doesn't matter which point you use as long as you use a real point on that line, or 2 real points on that line to create your slope, and then you can reduce or simplify as possible. So let's jump into example problem 10.1. I'm going to pause and write this up here for us so you don't have to sit here and watch me do it. Alright, so example 10.1 tells us to find the slope-intercept form of the equation of the line that passes through these 2 points. Don't let all of this throw you off. It's just a fancy way of saying what we've already been doing. We're looking for the linear equation, that is the equation of the line, that uses the slope-intercept format, and that is just the standard equation of the line, where when you have a slope of a line, it's going to cross the y-axis at some point. Okay, and we're looking for the slope, the up and down. So slope means up or down, right? So the up and down line is the y-axis. It's not the x-axis. The slope is how far up or down and the angle that it travels at. So don't let that throw you off. We're just looking for the equation of the line, or the linear equation that represents these 2 points. That's all we're doing. So the first thing we can do, there's 2 ways to solve this. There's graphically, we can graph it and solve it that way, or we can do it mathematically. Either way works. I'm going to graph it first, just because that gives us an illustration that we can use to verify when we do it mathematically. So first I'm going to graph -3, 1, 2, 3, and +2, 1, 2. That's right here. Let me use this green. That way it stands out better. All right, so that is going to be -3, +2. The next point is going to be +4, -3. So 1, 2, 3, 4, and down 3 because it's negative. 1, 2, 3, right there. All right, so that is 4 and -3. And there's that line. And so what I'm going to do is I've got to kind of figure out, I'm going to draw from here to here, right, and then I'm going to just stretch it out a little bit. and make sure I have my points aligned. There we go. Very good. So that works. So now I can kind of give myself an arrow here and an arrow here, and now my line is correct. And it goes through those 2 points. So one of the things that I can do is I can look at it visually and determine the slope. And the way you do that is by drawing corresponding to the axis. So this one's going to correspond to the y-axis, a line that's straight down. And then this point I'm going to draw straight across. Now, you could do this either direction. You just have to do one way and one the other way. So you could just as easily draw to a horizontal line this way and a vertical line this way. It wouldn't matter. You get the same slope. All right, so here is my intersection. So I'm going to count to the intersection of those 2 lines. 1, 2, 3, 4, 5. So the change in the y-axis is 5 spaces. So it moves 5 spaces. And then on the x-axis, it goes from here to here. So 1, 2, 3, 4, 5, 6, 7. So 7 spaces on the x-axis. So this is my slope. This is the slope of the line. So I can begin to write my formula. I can say y is equal to 5 over 7 x. Now I need to find the y-intercept. And it looks like it's not quite on the origin. It's not quite on the origin. And if it's not at an obvious point, right, it looks like it's off a little bit, like it's not right at the 0, then the thing to do is to sub. So we're going to sub one of these points, right, to find out what this intercept point is, because we can't tell what it is visually. So I'm going to take the y value here and I'm going to put it in. -3 is equal to 5 over 7, and I'm going to put in the x value, 4 plus b, and we're going to solve for the b. So now I have -3 is equal to 20 over 7 plus b. Now I need to turn this into a value, a fraction over 7 that equals -3. So -3 times 7, that's going to be -21. So -21 over 7. And I am going to, oh, you know what I didn't do? This is a negative slope because it goes down. So that is why. All right, so this is a -20 over 7. So when I bring it over here, I'm going to add it to both sides. So I'm going to add 20 over 7 to -21 over 7, and that's going to be my value of b. So my value is -1, 7 is equal to b. That is my y-intercept. So I can rewrite this now as y is equal to -5 over 7 times x minus 1 over 7. That is my equation of the line in slope-intercept form. Easy peasy. There's another way to do it. I'm going to take this and I'm going to move it over here so that we can use it by comparison. And then I am going to do this mathematically, and we'll just have our visual representation to help us out. So let's say I didn't have any graph paper and I needed to do my slope so that I could solve all that. All you have to do is the change in y for the change in x. So that means we have from point 1, let's call this 1, we'll call this 2, y1 minus y2 over x1 minus x2. And that's going to equal our slope. So here we have -3. I'm sorry, that's the x. I've got that in the wrong spot. So this will be +2 minus 3 -3, and then x1 is -3, and that's going to be -4. So that is going to equal 2 minus -3 is a +5, and -3 and -4, this is going to be a -7. We know the denominator can never be negative, So we move that up to the top, and that's negative 5 over 7. And we do have a negative 5, 7 slope right here. That matches. Now we're at the same place we were before. Y is equal to negative 5 over 7, x plus b. We would do the same thing, and we would sub in a point. Last time we subbed in this point. This time let's sub in this point, right? See if we get the same answer. So that'd be 2 is equal to negative 5 over 7 times negative 3 plus b. 2 is equal to 15 over 7 plus b. All right, so I need to make this the value of a denominator that equals 2. So that's going to be 14 over 7. I'm going to subtract this from both sides. Minus 15 over 7 equals b. Negative 1 over 7 equals b. Same answer. We used a different point and a different method. All right, so we would still get y is equal to negative 5 over 7, x minus 1 over 7. So it doesn't matter which method you use, you should get the same slope, you should get the same intercept point, and you should be able to write the same equation. All right, let's do another one. And I'm going to take a moment to write that up here for us. All right, so in example 10.2, we don't really have anything to graph. We can, we don't have to. But we are asked to find the equation of the line, which is the linear equation, that passes through the point negative 2 and 5 and is perpendicular to this line, 3y plus 4x equals 2. We can't use this in this format. It's not obvious what we need to do. So what we need to do is put it in format y equals, and that gives us the linear equation that is in slope-intercept form that shows us how to graph it. All right, so let's begin by putting everything over here where we can solve it. So the first thing I need to do is I need to move this 4x over here. So I'm going to subtract 4x from both sides. So that gives me 3y is equal to negative 4x, and that's a positive 2. Now I need to have y by itself, so I'm going to divide everything by 3. So y is equal to negative 4/3 x plus 2/3. That is my equation of the line that they have given me. But now I need to find the equation of the line that is perpendicular to that. And the way that we do that is we find the perpendicular slope. And the perpendicular slope is going to be the opposite number with the inverted fraction, or the inverted slope. So what that means is the opposite, we're going to multiply it times negative 1, it's going to make it a positive, and then we're going to flip the fraction. So 3/4 x plus b. We don't know what the b is because we don't know where it intercepts the y. But we do know this part. Now we need to find our b in order to find the equation of the line. We're going to do the same thing that we did before. We're going to pick a point, which is the only point we are given, and we're going to substitute it in for the y and the x. So we're going to say 5 is equal to 3/4 of negative times negative 2 plus b. 5 is equal to negative 6 over 4 plus b. Let's change this. 5 times 4 is 20. So 20 over 4, and then we're going to add this to both sides. So plus 6 over 4 is equal to b. 26 over 4 is equal to b. So I can reduce this down to 13 over 2. Sorry about that. My dog goes nuts when the UPS guy gets here. So we have 13 over 2 is equal to b. And so that would be what we put in for the equation of the line up here. So we would say y is equal to 3 over 4x plus 13 over 2. Sorry about that. At my house, if I don't have the door shut, people don't think I'm recording. So if you leave the door open, they're just going to start talking and walk in. So that is how we would find the perpendicular equation of the line, we find the slope, we take the opposite, and then we flip the equation, which gives us from a negative 4 over 3 to positive 3 over 4. And then we just sub in the point for the y and the x in order to find the b, and then rewrite it just like we would normally do. All right, we have one more. Let's do example 10.3. Maybe this time we can get through the whole problem without the dog barking or people walking in the room and chit-chatting. All right, so let me pause and clear this out for us. All right, example 10.3 says to find the equation of lines A and B. So let's start with line A, and I'm going to do it in the red color that A is illustrated in. So here we have a horizontal line where the y value is going to be a constant regardless of what point it is on the x, right? And that constant is going to be a -2. So we can say, because it's crossing the y-axis, that y is equal to -2. That's all you have to do for A. So let's look at B. B is going to be a little bit more complicated. We've got to find some points, and we've got to figure out slope. So this is our format because there is an angle to the line. It's going to be y equals mx plus b. So first of all, let's find an intersection point, and here's one at 6 and -1. Or actually, I got that backwards. That should be -1 is the x and 6 is the y. Okay, and let's see if we can find another intersection point. And I think there's one here. That looks pretty good. And this is at -6 and -5. All right, those are our 2 points. So we're going to find the slope of the line. Let's just do it mathematically. That'll be the fastest way, I think. So y1, let's say this is point 1 and this is point 2. So let's say that y1, that's going to be 6 minus a -5, so it's going to be plus 5. And then x1 is -1 minus -6 is going to be plus 6. So this is going to be 11 over 5. That is our slope. So y is equal to 11 over 5x plus b. Now all we need to do is sub in one of the points. So let's do that. I'm just going to use the first point, -1 and 6. So 6 is equal to, since this is a -1, I'm just going to go ahead and multiply, make this -11 over 5 plus b. And I am going to add 11 over 5 to both sides, but first I'm going to convert this into a fraction. So 5 times 6 is 30, so 30 over 5 plus 11 over 5 is equal to b. So 41 over 5 is my b. So I can write b, y is equal to -11 over 5. Is that -11? No. It's not -11. That was just because it was -1. I looked at the wrong one. So it's 11 over 5 x plus 41 over 5. And that is my equation of the line for B. All right. So those are fairly straightforward. Once you understand what each part of the equation of the line is, you should be able to solve these types of problems fairly readily. We did a lot of these in Algebra 2, so you should be fairly confident in this process. So let's look at rational denominators. So we remember that whenever we have square roots in our denominator, we really don't like it, right? So we want to get rid of having a square root in the denominator. But the way we need to do that is we don't know what this is going to be, and we are afraid it might end up being a negative number. So what we're going to do, we're going to conjugate this by using the opposite sign here. So let us multiply 2 minus 3 times the square root of 3 all over, or actually that's plus 2 plus 3 times the square root of 3. We did the opposite operation, and remember the radical always has to be second in order for this to work. So if it's not second, we have to reorder these and give it its proper sign. So now we change the operation and we can multiply. And remember, we have to use a process called stacking in order to do that. So we're going to stack these on top of each other. 4 and then a positive square root of 3. And then we're going to multiply it by this. So that's going to be 2 and a positive 3 times the square root of 3. We're going to multiply each of these times each above. So let's start with 3 times the square root of 3 times the square root of 3. So we know these two are going to cancel each other out, so it ends up being 3 times 3, so that's 9, and it's positive. All right, 3 times 4 is 12, so we have 12 times the square root of 3. 2 times the square root of 3 is just 2 times the square root of 3. And 2 times 4 gives us the whole number of 8. So now we have like numbers with like numbers, and we can combine them. So this is going to be 17, and this is going to be 14 times the square root of 3. And we're going to write that in standard format. That is going to be 17 plus 14 times the square root of 3. That's our numerator. Now we repeat the process for our denominator. We write the first number here, second number here. All right, so now 3 times the square root of 3 times negative 3 times the square root of 3. Well, 3 times negative 3, that's a negative 9. And this times this gives us another 3. So negative 9 times 3 is a negative 27. This is going to be 6 times the square root of 3. And this is going to be negative 6 times the square root of 3. And this is going to be 4. So now I can cancel these out, and then I can combine these, and that's going to be negative 23. And that goes in my denominator. All right, and remember that we actually want to take this, and we don't want a negative in the denominator. So we want to take this negative 1 out and move it up here and make the whole thing negative. And when we do that, our actual answer is going to be negative 17 minus 14 times the square root of 3 over 23. Because in order to change the denominator here, we have to multiply the top and the bottom by negative 1. Okay, it's easier to see that whenever you have just one number here, but when you have an operation, you really have to do this. You have to do that and that. It's more than just moving the negative sign to the top. You have to actually do the multiplication to see the real result. All right, so let's do one more. Let's do example 10.5 just to refresh our skills and remind us of how this works. We're going to use some imaginary numbers this time. So we're going to simplify this. This is example 10.5. We have 2 minus I cubed plus 2I to the 5th all over negative 2I plus 4. So first we need to write the complex numbers in standard form and combine as much as possible. So the first part, we've got 2 minus. Now we know that I squared is negative 1, so that would be negative 1 times I. And then here we would have 2 times negative 1 times negative 1 times I. So the numerator is going to resolve and be negative and negative is a positive. So it's going to be 2 plus I plus, because a negative and a negative makes a positive, 2i. So we can combine these two and say 2 plus 3i. Now we know that we need to put the I, the imaginary number, to the back. So this is going to be 4 minus 2i. Now we can conjugate and multiply. And we're going to multiply the top and the bottom by the opposite operation. 4 plus 2i on the numerator and the denominator. So when we do that, I'm going to stack it and do it over here. Let's do 2 plus 3i and then 4 plus 2i. And we know 2 times 3 is 6, and I times I is negative 1. 6 times negative 1 is negative 6. This would be 4i. This would be 12i. And this would be 8. So when we combine, we have positive 2 and 16i, and we write that in standard form. That's going to be 2 plus 16i right there. So now we're going to stack the bottom, the denominator. So we have 4 minus 2i and 4 plus 2i. So 2 times 2, that's a negative 2, so it's going to be negative 4 times negative 1, so it's going to be positive 4. 2 times 4, that's going to be an 8i. 4 times negative 2, that's going to be a negative 8i. And 4 times 4 is 16. So those cancel, and we're left with 20 in our denominator. And because this is an imaginary number, we don't leave it like this. We can't leave it all over the same denominator. It's not an acceptable format. We have to separate those. So we have 2 over 20 plus 16i over 20. Now we can reduce both of these. We know we can divide both of these by 2. That becomes 1 over 10 plus, this can be divided by 4, so it's going to be 4 over 5, 4i over 5. And that is our final answer for this problem. All right, so I hope that refreshed your memory. Let's move on to completing the square. Let's clear this out. If a quadratic equation is in the form of the two equations where we see some type of operation squared, the solution can be found by just taking the square root of both sides. Pretty straightforward. So for instance, if I were to have x minus 4 squared equals 5, all I would have to do is square it, right? Or unsquare it like this. So then I would have x minus 4, because these would cancel, is equal to the square root of 5. And that would be plus or minus the square root of 5, because we don't know if it is going to be a negative times a negative, which makes a positive, or the positive times a positive, which makes a positive. Then we're going to add 4 to both sides, and we end up with a positive 4 plus or minus the square root of 5 for that answer. Right? Pretty straightforward. And that's how we complete the square using the quadratic equation and radicals. So let's look at an example problem. Let's look at 10.6. Here we're going to solve this quadratic equation by completing the square. We have negative x plus 3x squared equals negative 5. Well, first we have to put it all in the right format. So the 3x squared goes in the front and the negative x goes in the back. And then we're going to add 5 to both sides. So that's plus 5, and that's all set equal to 0. Well, we know that we cannot have a lead coefficient when we want to factor. We have to get rid of lead coefficients. So everything gets to be divided by 3. That goes away first. So that gives us x squared minus 1/3 x plus 5/3. And that equals 0. So now we put this back over here. Now you can probably save this step, by just doing this. I'm going to back it up for just a minute. Rearrange this. See that we have a lead coefficient with our x squared, and know that we have to divide all of these by 3 from the beginning. So what that means is you can just skip all of those steps that we just did, those 2 or 3 steps, and just start there. X squared minus 1/3 x equals -5/3. That is the same place that we were at without having to write those 2 sentences. So you don't have to add it back to both sides and then rearrange and then divide by the lead coefficient. You can do that in your head. It's very doable. All we did was just leave this here, rearrange, and divide. Not a huge deal. So now what we need to do is we need to make room for we need to complete the square. We need to leave room for a new bit. I'm just going to scooch this over because I can. You're probably going to want to make sure you leave room when you write it down the first time. So I guess technically I should move the other part over. Let me do that. I just hate it when the equal signs, it's like a pet peeve of mine. I have to have the equal signs like lined up. It's just my thing. I just have to do that. All right, so now in order to complete the square, what we have to do is we have to divide this by 2. How do we do that? We're going to say -1/3 times 1/2, and that is going to give us -1/6. Double check my math here, and then we square that. So -1/6 times -1/6 is going to equal 1/36. This is what we're going to add to both sides. So plus 1/36 plus 1/36. And we need to put this in the same format so we can combine these together. So that's going to be multiplying everything by 12. 5 times 12, that's going to be 60. So I'm going to put 60 here, and that makes this 36. All right, because 3 times 12 is 36. So now I can combine these, and I know that -60 plus 1, that's going to be -59 over 36. You like how I just kind of erase that there and do all the calculations and don't show it to you? Then, yeah, not so much. All right, so now that we have -59 over 36, we can factor this here. And we already know that this is going to be the number that gets squared. So it's going to be x minus 1/6, and we square it. And that's going to equal -59 over 36. So we're going to unsquare it. We put everything under a radical, right? So that's x minus 1/6 is equal to plus or minus the square root of 59, -59, over the square root of 36, right? Okay, so I'm going to add 1/6 to both sides. X is equal to 1/6 plus or minus, and now we have a -1 in with this 59. 59, I feel like is, as a prime number, we can't factor that. So the only thing we can do is we can take that -1 out. So it's going to be the square root of 59i, and the square root of 36 is 6. And because it's an I, we can't combine these even though they're the same denominator. We're going to leave that just like it is. And that is our answer. X is equal to 1/6 plus or minus the square root of 59i divided by 6, or over 6. And that is solved. And that is the last practice problem, an illustration that we have for lesson 10. And I will see you in lesson 11. But we are almost 1/12 of the way through the book. So congratulations on your accomplishment. I'll see you guys in lesson 11. Bye for now.